Great day, learners! Welcome to another math learning experience. So what are you waiting for? Grab your pen and paper, your self-learning module, or your compendium of notes, and together, let's rock math. From the previous weeks, we have learned about the various theorems, properties, and key concepts of quadrilaterals. In this week, we will particularly use these learnings to solve problems involving parallelograms, trapezoids, and kites. How does that sound to you? Well, if you're ready, let's begin to unlock another math knowledge. Here are the steps or tips that we may want to consider in solving problems involving quadrilaterals. First, draw the quadrilateral with the given values. By illustrating, we get to properly visualize our problem. Second, we have to analyze the problem. In this step, we get to review all the properties and theorems relevant to the problem. And third is to finally solve the problem. Let's have problem number 1. For problem number 1, we have a general given, a quadrilateral wish, which is a parallelogram. For A, if the measure of angle W is equal to x plus 15, and the measure of angle S is equal to 2x plus 5, what is the measure of angle W? And for letter B, parallelogram wish is a rectangle and its perimeter is 62 cm. One side is 5 cm less than the other side. What are its dimensions and how large is its area? Now let's begin to solve for these problems. Let's start solving for problem A. Recalling the steps for solving problems involving parallelograms, trapezoids, and kites, the first thing that we should do is to draw the quadrilateral. Remember the general given, we have a parallelogram wish. And by problem A, it gives us the values or the measures of angles W and angle S. And we assign them in our illustration, wherein angle W is equal to x plus 15 and the measure of angle S is equal to 2x plus 5. By looking at our illustration, we can say that angle W and angle S are opposite angles. And we all know that the opposite angles of parallelograms are congruent. Therefore, we can use this property to solve for the problem. Since angle W and angle S are congruent, we can now equate their values. So we have here x plus 15 is equal to 2x plus 5. We combine like terms, we put the constants on the left side of the equation and the terms with variable x on the right side of the equation. We simplify, x is equal to 10. Now that we already solved for the value of x, we can now solve for the value of angle W. The original given for the measure of angle W is x plus 15. Since x is equal to 10, we can substitute. This becomes 10 plus 5. We further simplify, the measure of angle W is equal to 25 degrees. Here's a clear presentation of the 3 steps that we did to solve for problem A. We have here problem B, wherein there is a parallelogram wish, which is a rectangle, and its perimeter is 62 centimeters. One side is 5 cm less than the other side. What are its dimensions and how large is its area? The first thing that we should do is to draw the quadrilateral. In this problem, we need to illustrate a rectangle named wish. Let's say that line segment WI is equal to x, and the other side of the rectangle is equal to x minus 5 since one side is 5 cm less than the other side. Line segment WI and line segment HS are equal. Same goes with line segment WH and line segment IS. They are also equal because opposite sides of rectangle are congruent. Now let's analyze the problem. Earlier in our illustration, we let x be the longer side and x minus 5 be the other side. Since it's a rectangle, opposite sides are congruent. So to find the value of x and eventually the dimensions, we need to use the formula for perimeter of a rectangle, then we will find its area. The formula for perimeter is P equals 2 times quantity L plus W or 2L plus 2W. The values of the perimeter length and width are given, so let's just substitute it in the formula. So we have here 62 equals 2 times x plus the quantity x minus 5. Now let's simplify the values inside the parentheses. We got 62 equals 2 times the quantity 2x minus 5. We distribute 2. This becomes 62 equals 4x minus 10. We combine like terms. We put negative 10 on the left side of the equation. So this becomes 62 plus 10 equals 4x. We add 62 and 10. Its sum will be 72 equals 4x. We are solving for the value of x, so we need to divide both sides by 4. This becomes 72 divided by 4 equals 4x divided by 4. Then x is equal to 18. Now we can solve for the dimensions and the area of the rectangle. The length is equal to x. Since x is equal to 18, then it becomes 18 centimeter. Width is equal to x minus 5. Since x is equal to 18, we substitute x. This becomes 18 minus 5 or equal to 13 centimeters. Now the area of a rectangle is length times width. Therefore, we multiply 18 and 13. This becomes 234 square centimeters. Here is a clear presentation of the 3 steps that we did to solve for problem B. We have here problem number 2. For problem number 2, we have a quadrilateral POST or post, which is an isosceles trapezoid, and line segment ER is its midline. For letter A, if line segment ST is equal to 2x, and line segment PO is equal to x minus 5, and line segment ER, which is its midline, is equal to 38. How long is each base? Again, the first step that we should do is to draw the quadrilateral. Based on the general given, we have to illustrate a quadrilateral POST, which is an isosceles trapezoid, and ER is its midline. And then, we incorporate the values given by problem A, wherein line segment PO is equal to x minus 5. Line segment ER, or our midline, is equal to 38 centimeters, and line segment TS, which is equal to 2x. By looking at our illustration, we can say that in order to find the value of x, we need to use the equation in finding the midline of a trapezoid. In this case, we will use line segment ER is equal to line segment PO plus line segment ST over 2. Let's now solve the problem. We have here our formula line segment ER is equal to line segment PO plus line segment ST divided by 2. Let's substitute the given values. So this becomes 38 is equal to quantity x minus 5 plus 2x over 2. We simplify, this becomes 38 times 2 is equal to 3x minus 5. We further simplify, this becomes 76 is equal to 3x minus 5. We combine like terms by putting negative 5 on the left side of the equation. This becomes 76 plus 5 equals 3x. We add 76 and 5. This becomes 81 is equal to 3x. Since we still need to solve for the value of x, we need to divide both sides by 3. So this becomes 81 over 3 is equal to 3x over 3. And finally, x is equal to 27. Since x is equal to 27, we can now solve clear presentation of the three steps that we need to solve for problem A. We have here problem 3. In this problem, we have a given quadrilateral like, which is a kite. For problem A, it says here that Li is twice Le. If its perimeter is 240 centimeters, how long is Le? In this problem, we have to illustrate a quadrilateral like, which is a kite. Since Li is twice Le, we can say that the measure of line segment Li is 2x and the measure of line segment Le is x. By studying our illustration and by using the given values, we can use the perimeter of the kite to find the value of x and eventually the length of line segment LE. Particularly, we can use this formula for the perimeter. P is equal to 2 times the quantity line segment LE plus line segment LI. Let's now solve for this problem. Again, we will use the formula P is equal to 2 times the quantity line segment LE plus line segment LI. Since the perimeter, the line segments LE and LI are given, we will substitute it in the formula. So this becomes 240 is equal to 2 times the quantity x plus 2x. We simplify the terms inside the parentheses. This becomes 240 is equal to 2 times 3x. We get the product of 2 and 3x. This becomes 6x. And then we divide both sides by 6. So this becomes 240 divided by 6 is equal to 6x divided by 6. We simplify, x is equal to 40. Now that we already got the value of x, we can now solve for the value of line segment LE. Earlier, we know that line segment LE is equal to 2x. Since x is equal to 40, we substitute it in the formula. So this becomes 2 times 40, which is equal to 80 centimeters. Therefore, line segment LE is equal to 80 centimeters. Here's a clear presentation of the three steps that we did to solve for problem A. That's it for solving problems involving parallelograms, trapezoids, and kites. I know you guys did a good job in this session. I hope that you have learned and acquired something and you'll be confident enough to answer your learning tasks. Anyway, thank you for joining me up until this point of our video lesson. Let's see each other next time for another math learning escapade.